everyone, welcome to the optometriosis. In this video, we can learn a full detail about retinoscopy. Retinoscopy is an objective refraction technique that can estimate a person's refractive error. It should be done for every person that we examine as it gives us information that you cannot get any other way. It is also extremely useful for people who cannot communicate with us, such as young children or people with mental disabilities, because we can estimate the refractive error without needing to a subjective refraction. Doing a retinoscopy will make our refraction faster, more efficient and more accurate. Next one is structure of retinoscope. First one is light source. It projects a beam of light into the patient's eye. Second one is mirror or lens system. It directs the light. Third one is streak or spot mode. Depending on the type of retinoscope, the light can be streak or a spot. And last one is handle. It contains the power supply. And how it works means we shine a retinoscopy into a person's eye. We can look at a light reflected back from the retina. This reflect is known as retinoscopy reflex. The red reflex look like a red light inside the person's pupil. Depending on the person's refractive error, we can move the retinoscopy. The red reflex will move into a particular way inside the pupil, and the refractive error can be estimated accurately. There are two types of retinoscopy. First one is reflecting mirror retinoscopy, and it is an old method. Second one is self-illuminated retinoscopy. It has two subtypes. First one is streak and second one is spot. Nowadays a streak retinoscopy using in everywhere. So I explain you a detail about a streak retinoscopy. Next, the part of retinoscopy. In streak retinoscope, it has power switch, small globe, electrical supply, mirror, side hole and slide knob or sleeve. In power switch, it turn the retinoscope on and off. In small globe, to provide the light. In electrical supply, it is rechargeable, and in mirror, it reflects from the globe into the person's eye. In side hole, it to allow the red reflex to be seen, a viewing hole, and then slide knob to rotate the axis of the retinoscopy light. Next, the movement of the retinoscopic reflex. By moving the light from the retinoscope across the person's eye, this movement is called sweeping. Sweeping in different direction lets us look for astigmatism and measure the refractive error of the eye in different power meridians of the eye. Now we can see that first picture, sweeping the horizontal meridian. Use the slide knob to turn the streak to a vertical direction like 90 degree, and move the streak of the retinoscope from side to side along the horizontal meridian. Then second image, you can see the sweeping the vertical meridian. Use the slide knob to turn the streak to a horizontal direction like 180 degree. Tilt the retinoscopy up and down along the vertical meridian. And third one is sweeping the oblique meridians. Oblique meridians are neither horizontal nor vertical, but they are at an angle. Use the slide knob to rotate the streak to an oblique angle, for example 45 degree, and move the retinoscopy in a direction that it is at right angle to the streak direction, for example 135 degree. If you are practicing a retinoscope, first shine the streak on a wall and sweeping the horizontal meridian and vertical meridian and oblique meridian. Next, you can view through the sight hole. When you look through a retinoscopy at a person's eye, you will see the red reflex. When you shine the light into their pupil, the red reflex usually looks like a narrow band of red light that covers part of the pupil. If you have the trial lens in the trial frame, you will also see the light reflected on the rim of the trial lens. When you move the retinoscopy, the red reflex also moves. The movement of the red reflex may be the with or against or neutral. Now you can see that image, a red reflex showing with movement. When the red reflex moves in the same direction as the sweeping motion of the retinoscope streak, then it is called with movement. Next you can see this picture, a red reflex showing against movement. When the red reflex moves in the opposite direction to the sweeping motion of the retinoscope streak, then it is called against movement. And then This picture shows neutrality, which means the whole pupil is filled with light and there is no movement of the red reflex during sweeping. Then it is said to be neutral point or neutrality. Next, you can see the image in characteristic of red reflex. As you get closer to neutrality, the red reflex become wider. First characteristic of red reflex is brightness. The reflex get brighter as you get closer to the neutral point. And second one is direction of movement. With movement is neutralized with plus lens and against movement is neutralized with minus lens. Third one is speed. The speed of the reflex gets faster if it is close to the neutral point. The fourth one is thickness. The red reflex becomes wider when it gets close to the neutrality. You can see this flow chart. It is the easiest way to remind you the characteristic of red reflex. Next is most important thing, working distance. When you do retinoscopy, you are usually 67 centimeter away from the person or sometimes 50 centimeter. This distance is called the working distance. The working distance is extremely important because you need to remember it when you calculate a person's refractive error after doing retinoscopy. If you are practicing a retinoscopy, you can use a piece of string to measure your working distance. One end of the string is tied to the retinoscopy and the other end is pulled tight to touch the person's trial frame. The string should be 67 centimeter long. This will help you learn to feel the correct retinoscopy working distance. With practice, you will know the correct distance without using the string. And next one is neutrality and working distance. When the neutral point is reached, it means that the person's retina is in sharp focus. If you were 6 meters away from the person being examined, the lens needed to neutralize the reflex would be the same as the person's refractive error. But being 6 meters away from the person is impractical. So you must sit closer to that person. Usually, we choose to hold the retinoscope 67 centimeter away from the person's eye because this let us hold trial lens in front of the person's eye with an arm outstretched. If you are any closer than 50 centimeter to the person, your retinoscope results will not be as an accurate because you are not 6 meter or more away from the person. You must compensate for your working distance with you calculate the person's distance refractive error. If you use a working distance of 67 centimeter, you have and then you subtract 1.50 diopter from the lens power that neutralize the red reflex. Because f is equal to, we have that formula 1 by f is equal to 1 by 0.67. We have to convert 67 centimeter into meter, then we have 1.550 diopter. There are two ways to compensate for the retinoscopy working distance, and first one is calculation method and second one is extra trial lens method. Now we can see that calculation method. First we find the trial lens that give neutrality and depending on your working distance subtract 1.5 or 2 from the power of these trial lens, and final this is the power of the lens that will correct the person's refractive error as measured in retinoscopy. Now you can see that first example, a person with plus 5, a neutral red reflex at a working distance of 67 centimeter. Now we can subtract 1.5 diopter and the person's refractive error measured by retinoscopy is plus 3.5. So we know that this is hyperopia. And in second example, a person with minus 5 diopter, neutral red reflex at a working distance of 67 centimeter. Now we can subtract minus 1.50. Then the person refractive error is minus 5.50. Then it is said to be a myopia. And second method is extra trial lens method. Before we begin retinoscopy, first put plus 1.5 or plus 2 trial lens into the back cell of the trial frame and leave them there itself. And find the trial lens that give neutrality and put these lenses into the front cell of the trial frame to differentiate. And remove the plus 1.5 or plus 2 trial lens from the back cell of the trial frame. And the trial lens that are left in the front cell of the trial frame are the equal to the power of the lens that will correct the person's distance refractive error as measured by the retinoscopy. We finish your retinoscopy and how we know that it is done with right or wrong. So I will tell you a detail about checking neutrality. There are three ways to check. First one is checking your working distance. If you change your working distance, the red reflex that you see will also change. First one is moving forward closer to that person. This will shorten the working distance. So the red reflex should become with movement. If you moving backward further away from the person, this will lengthen the working distance. The red reflex should move against movement. You can see that picture changing your working distance to check neutrality. And second way is changing your light beam from divergent to convergent. Usually you will keep the retinoscopy slide knob down so that you use the divergent beam to do retinoscopy, and this gives width against moment with when you need to add plus or minus. If you push the slide knob up, the light beam will become convergent. This gives against movement when you need to add plus, with movement when you need to add minus. If you do not have neutrality, changing you from divergent to convergent light will cause reversal to the red reflex. Width will become against and against will become width. If you have neutrality, changing from divergent to convergent light will not change the reflex. Third way is adding plus 0.25 diopter and minus 0.25 diopter. If you have neutrality, adding plus 0.25 diopter gives against movement and adding minus 0.25 gives with movement. Next one is alignment of streak and red reflex. The streak of light from a retinoscopy can be rotated so that all meridians of an eye can be examined. Usually the horizontal meridian is scoped first, then the streak is rotated so that the vertical meridian and the oblique meridians are examined. Note, the power meridian is always perpendicular to its axis. To scope a meridian, the streak is rotated so that it is perpendicular to the meridian. This means that the streak direction and the axis direction are the same. When the streak is vertical 90 degree, the horizontal 180 degree meridian of the eye is being scoped. The meridian has an axis of 90 degree like the orientation of the streak. When the streak is horizontal 180 degree, the vertical 90 degree meridian of the eye is being scoped. The meridian has an axis of 180 degree. When the streak is at an oblique angle, the meridian perpendicular to that oblique meridian is being scoped. This meridian has an axis that is the same as the orientation of the streak. In this picture, a retinoscopy scope showing a spherical refractive error. If a person has a spherical refractive error, the red reflex will look the same in all meridians. The red reflex will be neutralized in all meridians by the same trial lens power. As the streak is rotated, the red reflex stays parallel to align with the streak in all meridians. A spherical refractive error has no break. In all meridians, the red reflex has the same brightness, speed and width, and it will move in the same direction. In spherical refractive errors need the same optical correction in all meridians. You can turn the streak in any direction and the brightness, direction of the movement, speed and width of the streak will be the same in every meridian. And in this picture showing the astigmatic refractive error, if a person has an astigmatic refractive error, the red reflex will look different in different meridians. The red reflex is neutralized in each of the two principal meridian by trial lens of different powers. As the streak is rotated, the red reflex will only be parallel to the streak in two meridians. These are the principal meridian of the person's astigmatism. When the streak is at another meridian, not at principal meridian, the red reflex has the streak will no longer be aligned. A break in the red reflex will be seen. Each principal meridian needs to be neutralized separately. In each of these two principal meridians, the red reflex will have a different brightness, speed, width, and it may move in different direction. The principal meridian may be at any orientation between 0 degree and 180 degree, but they will always be perpendicular at right angles to each other. This figure shows that 45 degree and 135 degree, the red reflex is parallel to the streak. It is not parallel to the streak in other directions such as 90 degree and 180 degree. This means that is person has astigmatism and the principal meridians of the astigmatism are at 45 degree and 135 degree. In astigmatic refractive error, we need different optical correction in different meridians. An astigmatic eye has two principal meridians that are perpendicular 90 degree to each other. The principal meridians are the meridians of the maximum and minimum power. The red reflex for each of these principal meridian will differ in brightness, speed, width, and maybe direction of movement. Finding principal meridians. If you are sweeping your streak over one of the principal meridians, we say that you are on axis. If you are not sweeping over one of the eye's principal meridians, we say that you are off axis. To help you scope on axis, look at the break, brightness, width or thickness characteristic of red reflex. First one is break. If the red reflex is not aligned with the streak, if there is a break, you are then scoping on axis along one of the principal meridians. In second, brightness, rotate the streak and look at the change in the red reflex brightness. And third one is width or thickness. Rotate the streak and look at the change in the red reflex thickness. Now you can see that picture thickness of the red reflex in on axis and off axis. Streak retinoscopy procedure and method. The retinoscopy is usually done with the both examiner and the person being examined seated. Room light should be dim. If the room lights are too bright, it is difficulty to see the red reflex. If the room is too dark, it is difficulty to see what you are doing. And ask the person to look at a large fixation target that is at least 3 meters away from them. A large fixation target like the corner of the visual acuity chart or a 6 by 60 letter helps to relax the person's accommodation and keeps their eyes steady. And adjust the trial frame to the person PD and make sure that it fits them comfortably. You need to make your line of sight through the retinoscopy as close to the person's visual axis, looking at the fixation target as possible. Moving away from the person's visual axis will make your retinoscopy results less accurate. To do this, sit facing the person so that your head is in front of their right eye. The person should still be able to see the fixation target with their left eye, but your head will block the eye view from their right eye. Make sure that your eyes are at the same height as the eyes of the persons that you are examining. Keep your head straight. The person needs to look past your ear. If you tilt your head, you could block the fixation target that your person is looking at. Make sure you are the correct working distance from the person. Calculate the power of compensation you need for this working distance. Insert working the lenses of this power into the back cell of the trial frame, or remember this power so that you can subtract this amount from your final result at the end. Blur the eye not being examined with the plus lens to minimize accommodation. Usually a plus 1.50 diopter or plus 2 working lenses works well. Check that the retinoscopic beam is divergent by moving the slide knob to its lowest position, closest to the battery handle. Always examine the person's right eye first. To hold the retinoscopy in your right hand, looking through the retinoscopy with your right eye, rest the top of it against your eyebrow or forehead. Sweep the person's right eye with the stick. Examine the person's left eye second. Hold the retinoscope in your left hand, looking through the retinoscopy with your left eye. Sweep the person's left eye with the stick. Look through the retinoscopy while keeping both of your eyes open. With practice, you will learn to suppress the other eye. If you close your other eye, when you do retinoscopy, you can give yourself a headache. Tell the person, keep looking at the target. Please tell me if my head gets in the way and you cannot see the target anymore. The target might be blurry. Don't worry about that. Just relax and keep looking in the direction, and tell the person, please keep both of your eyes open. Then keep reminding the person to look at the fixation target and not at your retinoscope light. And there are two methods to neutralize astigmatic refractive errors. First method is using spherical and cylindrical trial and second method is using spherical trial and an optical cross. Both methods are useful and correct, but if you are using a retinoscopy rack, you will probably find the second method more useful. A retinoscopy rack means it is a piece of equipment that contains many different spherical lenses in different powers. It can be more convenient to use a retinoscopy rack instead of trial lens. But if you do not have a retinoscopy rack, a trial lens set will give you accurate result. And we see a detail about method 1 neutralization using spherical and cylindrical trial lens. First step is find the most plus or least minus meridian for the right eye. If there is with movement in one meridian and against movement in other meridian, neutralize the with movement first. If there is with movement in both meridians, neutralize the more hyperopic meridian first. This is the meridian that has a red reflex that moves slower, is thinner and is less bright than the other meridian. If there is against movement in both meridians, neutralize the least myopic meridian first. This is the meridian that has a red reflex that moves faster, is thicker and is brighter than the other meridian. And step 2 is neutralize the most plus or least minus meridian using a spherical trial lens. Put the spherical trial lens that neutralize this meridian into the trial frame. And step 3 is to rotate your retinoscopy streak 90 degree and neutralize the other principal meridian. A minor cylinder trial lens is used to neutralize this meridian. And step 4, put a minor cylindrical trial lens into the trial frame on top of the spherical lens that is already in there. The power of the minor cylindrical lens will be equal to the neutralization lens that you found in step 3. The axis of the minor cylindrical lens will be in the same direction as your streak orientation in step 3 also. Rotate your streak and check that all meridians are neutralized. If there is still with or against movement, repeat step 2 to 5. If all meridians are neutralized, and go to the step 6. And the step 6 is to repeat 1 to 5 steps for the left eye. And step 7 to check the measure that the right eye is still neutralized. If the right eye now shows with movement, it was accommodating when you neutralized it in the first time. This may be because not enough plus was in front of the left eye to relax the accommodation. You will need to add more plus to neutralize the right eye again. Step 8. Write down your retinoscopy finding. This is an objective measurement of the person's refractive error. Remember to compensate your working distance before writing your retinoscopy findings. And step 9. Measure the visual acuity for the right eye and left eye through the neutralizing lens that you have found. And method 2 is neutralization using spherical trial lens and an optical cross. Step 1. Find one principal meridian for the right eye. And step 2 is neutralize this principal meridian using spherical trial lens. And step 3 is draw a line on a piece of scrap paper in the direction of your streak and write the power of the lens needed to neutralize it. This line represents the axis of the meridian that you have just neutralized. And step 4, rotate your retinoscope streak 90 degree and neutralize the other principal meridian. And step 5, on your paper draw another line perpendicular to the first line to make an optical cross. Next to this second line, write the power of the lens needed to neutralize this meridian. This second line represents the axis of the second meridian that you have neutralized. And step 6, look at the most plus or least minus of the two powers on your optical cross. Put a spherical trial lens of this power in the trial frame. And step 7. Look again the two powers on your optical cross. Subtract the most plus or least minus power from the least plus or most minus power. Choose a minus cylinder of this power and put it in the trial frame in front of the spherical lens from step 6. Turn the axis of the cylinder so that it is in the same direction as the least plus or most minus power on the optical cross. Power of minus cylindrical lens to put in trial frame from the optical clause, least plus most minus power minus most plus least minus power. We have to minus. And step 8, rotate your streak and check that all meridians are equalized. If there is still with or against movement, repeat step 1 to 8. If all meridians are neutralized, then go to the step 9. And the step 9 is to repeat 1 to 8 for the left eye. And step 10 to check to make sure that the right eye is still neutralized. If the right eye now shows the with movement, it was accommodating when you neutralized it in the first time. This may be because not enough plus was in front of the left eye to relax the accommodation. You will need to add more plus to neutralize the right eye again. And step 11, write down your retinoscopy finding and remember to compensate your working distance before write your retinoscopy findings. And step 12, measure the visual acuity right eye and left eye through the neutralization lens that you have found. With practice, you will need to draw the optical cross. You will be able to remember the meridians and their powers if in your head without needing to write them down. Here some examples are shown. I will explain the example 2, hyperopia and astigmatism in method 1. First step, to compensate for the working distance, and second step, scoping the meridians. You sweep the horizontal, vertical and oblique meridians as shown in this picture. You recognize that the principal meridians are at 15 degree and 105 degree. From this picture, you can see the red reflex is different in different meridians. It is an astigmatic refractive error. The principal meridians are at 15 degree and 105 degree. Notice that two principal meridians are perpendicular to each other. The red reflex gives with movement in both principal meridians. There is a hyperopic refractive error in both principal meridians. The plus lens are needed to neutralize the red reflex in both meridian. The red reflex is slower in the 15 degree meridian at axis 105 degree. This meridian must be the most plus. Faster in the 105 degree meridian at axis 15 degree. The meridian must be the least plus. Remember, first neutralize the slowest with against, neutralize the fastest against moment, and second neutralize the fastest with moment and neutralize the slowest against moment. And step 3, neutralize the red reflex in the 15 degree meridian, streak at axis 105 degree. Because the red reflex shows with movement in this meridian. You try plus 1 trial lens, it gives with movement in 15 meridian. You try plus 2 diopter trial lens with movement in the 15 degree it gives. And plus 3 it gives against movement in the 15 degree. And you try plus 2.5, it gives with movement in the 15 degree. And you try plus 2.75, it gives neutrality in the 15 degree meridian. And you put a plus 2.75 diopter trial lens into the trial frame in addition to the plus 1.5 diopter working lens in the back cell of the trial frame. And neutralize the red reflex in the 105 meridian, streak at axis 15 degree. The red reflex now shows against movement in this meridian. You put one cylindrical lens trial lens into the trial frame at axis 15 degree. This gives against moment in the 105 degree meridian. You put minus 2 cylindrical lens into the trial frame at axis 15 degree. This gives with moment in the 105 degree meridian. You put minus 1.5 diopter trial lens into the trial frame at gives 15 degree at axis 15 degree. This gives neutrality in 105 degree meridian. And you check to make sure that the red reflex in the 15 degree meridian at axis 105 degree is still neutralized. If it is not still neutralized, you must scope both meridians again. And checking your retinoscopy results with plus 2.75 minus 1.5 into 15 degree, and your working lens in the trial frame is trial frame, you decrease your working distance as you move closer to the person, and this gives with movements in all meridian. Increase your working distance, you move further away from the persons. This gives against movement in all meridian. From this, you know that both principal meridians in the right eye are neutralized by plus 2.75 minus 1.5 into 15 degree. Then repeat for the left eye. You find that the left eye neutralized with plus 3 and minus 1.75 into 165 degree lens. And recheck the right eye. You now find that plus 2.75 minus 1 into 15 degree lenses give with moment in both principal meridians. And you add plus 0.25 diopter to the trial frame. This total of plus 3 minus 1.5 into 15 degree now gives neutrality in both principal meridian. From this, you know that that the person was accommodating when you first did retinoscopy on the right eye. And remove the working lens and put the neutralization lens into the trial frame. You leave the neutralizing lens in the trial frame. You measure the person's visual acuity with these neutralizing lens and write down the retinoscopy result and visual acuity. Like right eye is equal to plus 3 minus 1.5 into 15 degree. In visual acuity is 6 by 7, 5 plus. And here some common mistakes are done in retinoscopies are incorrect working distance or poor patient fixation or sweeping too far away from the person's line of sight or poor identification of the principal meridians. And the problem seeing the red reflexes are high refractive error, cataract, corneal scare, corneal opacity, large pupil, small pupil, vitreous opacities, and uncontrolled accommodation. Okay guys, I explained a full and deep detail about what is retinoscopy, why we do retinoscopy and structure of retinoscopy and how it works and types, parts, and a detail about streak retinoscopy and its movement of reflex and characteristic of reflex and working distance and working distance methods and streak retinoscopy methods and procedures with examples. Please subscribe my YouTube channel to see more videos. Let's meet you in next video. Thank you.